Hello, this is Mr. Collier, and today we're doing permutations, okay? And we're going to do it by considering counting principles without the formula, as you're going to see in a second. All right, so let's take a look at this first example. We've got cards A, B, C, D, E. How many ways can you arrange two of them so they're placed in lines? So they're placed in a line, like that kind of implies the order matters. And when the order matters, we call that a permutation. Okay, the order matters. So let's first start by just making an organized list to see all the possibilities. You could have the first card as A, second card as B, or AC, AD, AE. There's 4 possibilities for starting with the letter A. Or the first card could be B and then A, and then BC, BD, BE. So again, 4 possibilities. And you can do that with the starting letter of C or D or E. So this is 4 possibilities for each, and there's 5 possible starting values or cards. So it's 4 times 5. Well, let me write that as 5 times 4, which is 20. Okay, you can also just set it up like this. I like to draw blanks, so it's representing the possible cards. So the first card, there's 5 possibilities for the first card. And then once you pick your first card, there's 4 possibilities for the second one. And you can simply just multiply and get 20. Okay, and now for part B, all 5 of them, well, I'm going to do the blank method again. And just count the possible ways for the first one. There's 5 possible ways for the first one. Then 4, 3, 2, 1. Okay, so this, you just multiply these numbers together, and there's a special symbol for that, 5 factorial. Multiply these numbers together, you get 120 ways. Okay, so the factorial symbol is very important for combinatorics when you're counting permutations. There's 5 factorial ways to arrange any objects. Now, here's a permutation formula which we don't really need to use. We can always use the blank method I just outlined. But notice it works for this first one here. If we had a choice of 5 letters and we're picking 2 of them, then according to this formula, you would do 5 factorial divided by, let's write it out, 5 minus 3 factorial, which is 5 factorial over 3 factorial, and then that is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. So you see it's just 5 times 4, which is the same as what we did up there. So this formula works for this here, but you can just use the blank method, right? Anyway, let's look at some examples. 3-digit number is formed with 3 cards labeled 0 to 9. Okay, so a 3-digit number. Now, if you start with a 0, that's not really a 3-digit number. That's a 2-digit number. So for this first part, how many ways are there to make this can be done if the same number, maybe I should say the same digit or card, can be used more than once. So everything's okay for the first one except for 0. So there's only 9 possibilities for the first digit. And then for the second digit, you can have a 0. So there's 10 possibilities from 0 to 9. And 10 for the last one. So there's 900 possible ways. If this is like a bicycle combination lock or something, you can have 0 at the beginning. So for a bicycle combination lock, you would have 10 times 10 times 10. Now part 2, only once. Let's set up some blanks. Still, there's 9 possibilities for the first one. Now you've picked one number for the first digit, so there's only 9 possible for the next one. And then there's 8 possible for the last one, so that's 648. Now part B, if the numbers can be used only once, how many numbers greater than 700 can be formed? Well, the first digit has to be a 7, 8, or 9. So that's 3 ways. And the next digit, there's 9 possibilities and 8 possibilities for the last digit. So that's 216. Now the last one's a bit trickier. Odd numbers greater than 700. So if it's an odd number, the last digit is odd, like 1, 3, 5, 7, or 9. Okay, but you have to be careful. You have to do 2 cases here. Okay, so you have to do the case of first digit odd or first digit even. Okay, and you'll see why in a second. If the first digit is odd, for instance, there's only two possibilities, then 7 or 9. So there's two possibilities for the first digit. But when you look at the last digit now, there's only 4 possibilities because you've used up one of the 5 odd digits. And the middle one, well, there's 8 digits left, so that's going to be an 8. And for first digit even, that's if you start with an 8, so there's only one possibility for that. But since you have an even digit here, there's a 5 here. There's 5 odd digits to choose from, and there's still 8 in the middle. So you see why we have to split it. This last one digit, or the last number of possibilities, the number of possibilities for the ones digit depends on the leading digit or the hundreds digit, right? So you do have to split that into 2 cases. And sometimes you have to do that. And it's 104 ways. Let's look at a couple more questions that sort of look more like IB questions. Soccer team consists of boys and girls, 2 boys, 3 girls. They're standing in a line, so the order matters. Find a number of arrangements. Arrangements kind of implies permutation as well, or the order matters. All boys stand next to each other and all girls stand next to each other. So if you think about it, all the boys could be on the left and the girls on the right, or the other way around. So that when you do the number of possibilities, you're going to have it times 2. Okay, because you can always rearrange them. But there's 2 boys in that group. The number of ways to arrange 2 boys is 2 factorial, or just 2. All right, and then there's 3 girls. So the number of ways to arrange the girls is 3 factorials. It's 3 of them. The number of ways to arrange any group of 3 objects is 3 factorial, or 6, right? So when we multiply that, we get 24. Now let's look at part B. All the boys stand next to each other. So one way to do that is you can consider 3 different girls, and I'm going to label them G1, G2, G3. And the boys are just like one group, or you treat them like one person. It's the same thing as like there's 3 girls and 1 boy, because the boys are together. So it's really like 4 people, if you consider that one person. So that number of ways to arrange these is 4 factorials. But then the boys, they could be left, right, or right, left. So there's 2 ways to arrange those boys. And that gives you 48 possibilities. Okay, next, number C. All the boys are apart and the girls are apart. There's only one way that can happen. It has to be a girl on the left, and then boy, girl, girl. This is the only way you can get the girls split up, is you put the boys in the 2nd and 4th position, right? So there's only one way that can happen. And there's 2 boys again. You can rearrange those 2 boys in 2 ways. And the 3 girls, again, you got a 3 factorial. So that is 12. And the last one, D. Just the boys are apart. Now, there's lots of ways that can happen. You can start off with a boy, then it has to be a girl. Then you can put in a boy, girl, girl. Or you can do boy, girl, girl, boy, girl. Boy, girl, girl, boy. That's all the possibilities. Starting with a boy. Then we can do girl and a boy in the 2nd position. Then it has to be a girl. And then we can do boy, girl. Or girl, boy, girl, girl, boy. And there's one more possibility. It could be girl, girl, boy, girl, boy. These are all the possibilities. So that's 6. And then again, there's 2 boys and 3 girls. So this is the number of ways to arrange the boys and the girls. So that is 6 times 6 times 2 is 72. Okay, let's look at the next example. This is a seating arrangement of 10 desks. Sorry, there's a bit of a typo here. This is meant to go down here next to B. Find the number of ways 10 students can be arranged in this lab. So this is the same as the number of ways 10 students could line up in a row. Like there's 10 possibilities to put a student at desk 1, 9 here, 8, and so on. So this is just 10 factorial, which is a huge number. Let's do this on our calculator. You can, actually let me get into a new app, not the finance app. And I can do 10, and then the factorial button I think is over here somewhere, but you can also go to Toolbox, Probability, Factorial. So it is a huge number, 3,628,800. Part B, find the number of ways students can be arranged if Hugo and Leo must sit so that one is directly behind the other. So that can happen. Well, you can choose desk 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. So it's 5 ways of doing that. And Hugo could be in the front, Leo in the back, or the other way around. So there's 2 factorials ways to arrange Hugo and Leo. And there's 8 more students, so that is 8 factorial for the rest. And this gives you 403,200 if you type that into the calculator. And lastly, what if Hugo and Leo must not sit next to each other in the same row? Sometimes it's easy to do the total minus the opposite of that. Number of ways Leo and Hugo sit next to each other. So you can do it other ways, but this is probably the easiest way to do it. So the total, we already have it, is 10 factorial. The number of ways they can sit next to each other is, well, they can sit in desk 1, 2, 2, 3, 3, 4. That's 4 ways on the top and 4 ways on the bottom. There's 8 ways of that happening. And again, you can arrange Hugo and Leo. You can swap them in 2 ways. And the other 8 students is 8 factorial. And if you type that in, you get 2,983,680.